Hello students, let us go ahead on the journey of vectors. Today I am going to explain the three simple concepts of the vectors. These are position vectors, components of a vector and section formula. So these three are very simple and will help us to learn the concepts of the rest of the topics. So let us go ahead. First of all, let us discuss about position vector. To calculate the position vector of a point, we need to calculate its position with respect to a fixed point, and this fixed point is origin. So, if we are having a point A and we need to calculate its position with respect to the fixed point, that is origin, then the position vector of this point A with respect to O is called as OA, and it is nothing but simply position vector of point A. So, similarly, if we are having a vector, then a vector can also be expressed in terms of position vector. So, how? Let us visualize it by taking one vector AB. This is vector AB directed from A to B. Now, we need to calculate vector AB. But as I told you, that first of all we need to calculate the position of point A as well as position of point B with respect to O. That is the position vector of point A and position vector of point B. So let me take one point O over here, and as I just told you that OA is the position vector of point A and OB is the position vector of point B. For that, let me join OA and OB. So, OA is the position vector of point A. Let us name it as A. And OB is the position vector of point B, and let us name it as B. Now, to calculate the vector AB in terms of position vector, let us use triangle's law of addition. Triangle's law of addition. ABO is the triangle. So, according to the triangle's law of addition, we are having vector AB is equal to vector AO plus vector OB. Now, we have taken position vector of A as OA is equal to vector A, and position vector of B is OB, which we have given the name as vector B. So, therefore, vector AB is equal to, if we write it as, then AO will be minus A. It is minus A vector and OB is plus B vector. What are we getting? We are getting that vector AB is equal to vector B minus vector A, or we can say OB minus OA, or we can write it as that vector AB can be written as position vector of B minus position vector of A. So, therefore, a vector can be represented in terms of position vector of its points, initial point and terminal point. But the thing that we need to take care is, if we are talking about, let me take vector PQ, then it will be position vector of Q minus position vector of P. Okay, the order should be position vector of Q minus position vector of P. Let me take one more example. If we need to find out position vector, if we need to find out vector C in terms of position vector, then it will be position vector of D minus position vector of C. So, in this way, we can represent a vector in terms of position vector of the points, and the order should be followed strictly. To understand the concept of position vector, let me take one example in front of you. So, here is one example in front of you. It is the position vectors of point A and B are given 5A plus 2B and 3A minus B respectively. Find the vectors AB and B. So let me start the solution by writing position vector of A is equal to, as I told you, we can express it in terms of OA, which is given to us as 5A vector plus 2B vector. This is given to us. And position vector of B, we can represent it as OB is equal to 3A minus B. Now, as we know that that vector AB is equal to position vector of B minus position of the vector A, means the position vector of terminal point minus position vector of initial point, or OB vector minus OA vector. It is given that position vector of B is 3A minus B vector, and minus position vector of A, that is given to us as is 5A vector plus 2B vector. So it will be minus 5A vector minus 2B vector. So the vector AB that we are getting is minus 2A minus 3B vector. Now the second thing, let us calculate BA vector, which is equal to position vector of A minus position vector of B. So therefore, now let us write the values. Position vector of A is 5A plus 2B, and position vector of B is 3A minus B, that it will be 3A plus B. So therefore, vector BA we are getting as 2A vector plus 3B vector. So this is how to calculate a vector in terms of its position vectors. Now let us learn how to prove the given points as the collinear points by using the same concept, that is concept of position vector. So the problem is, show that the points having the position vectors, this one, that is minus 2A plus 3B plus 5C, and A plus 2B plus 3C and 7A minus C are collinear. So the collinearity condition is, if we are having two vectors, let me name these vectors AB and CD. So if we are having these two vectors, then AB and CD are collinear when we have vector AB is equal to lambda times CD, where lambda is a constant. It may be negative, positive, or in root also. So if AB vector is equal to lambda times a constant into another vector, then these two vectors are said to be collinear. One thing more I want to add over here, let the two vectors are AB and BC. And among these we are having a relation, as I told you, vector AB is equal to lambda times vector BC. And the other thing that I have taken here is vectors AB and vector CD. So two cases may be arise with the same condition, AB is equal to lambda times CD. So in first case, let me name it as case 1 and it as case 2. So in case 1, as B is the common point out of AB and BC, let me draw it. This is the point A, B, and the third point is C, and it is directed from like this, AB, BC. Now as B is the common point and we are having the relation AB is equal to lambda times BC, it means A, B, C are collinear. There is no case other than collinear. But if the case is of like ABCD, means no common point is here. So two cases may arise. Number one, these 4 points may be collinear. Number two, these two vectors AB and CD are parallel. So for the second case, we can take it as A, B, C D are the 4 points directed A, B, B, C, C, D. So if we are getting the result vector AB is equal to lambda times vector CD, then this may be the case that A, B, C, D are collinear. Second case may also arise that vector AB and vector CD are parallel to each other. Like these are the two vectors which are parallel to each other. This is, let me name it as A, B vector directed from A to B, and this is vector CD directed from C to D. So these two are the parallel vectors. So the condition remains same for parallel and collinear vectors. That is, one of the vector is lambda times of the second vector. So these may be collinear or these may be parallel. If a point is common out of these, then there is no case of parallel. But if no point is common, then they may also be parallel. Now let us complete the question that how to find out that whether these 3 points are collinear or not. First of all, let me take the position vector of the points. Let me write position vector of A, that is the first point which is given to us. The first point which is given to us is position vector of first point given to us is minus 2A vector plus 3B vector plus 5C vector. Let me name the second point as B. So position vector of point B given to us as vector A plus 2B vector plus 3C vector. And the third, let me name the third point as point C. So position vector of C is 7A vector minus C vector. So as just I told you that we need to find out whether there is relation AB, BC with lambda times or not. So let me calculate vector AB. And we know that vector AB is OB minus OA. So clearly OB is equal to vector A plus vector 2B plus vector 3C plus vector 2A minus vector 3B minus vector 5C. So we are getting vector 3A minus vector B and minus vector 2C. This is AB. Now let us next calculate BC. Vector BC is OC minus OB. So OC we are having with us as vector 7A minus vector C, and OB we are having minus vector A minus vector 2A minus vector 3C. Let us calculate. So we are getting 5A vector. Let us write the values of OC and OB. OC we are having vector 7A minus vector C, and OB we are having as this. So it will be minus A vector minus 2B vector minus 3C vector. So on calculations we are getting vector 6A minus vector 2B and minus vector 4C. Its addition is same as we have done in algebra. So if we solve it further, we find that we can take 2 common out of the 3 expressions. So we are left with vector 3A minus vector B and minus vector 2C. So if we compare AB vector and BC vector, so we are getting that BC vector is equal to twice of AB vector. So here value of lambda is 2. So therefore these 3 points are collinear. So we can say that A, B, C are collinear. In this way you can prove easily that whether the given points are collinear or parallel or having same condition. Now let me start the next topic, which is components of a vector. To explain components of a vector, let me take a coordinate plane. This is the coordinate plane with y-axis and x-axis, and O is the origin. Let us take one point P over here in this coordinate plane. Let xy be the coordinate of this point P. Now, as you know very well that if a point P is over here with coordinates x and y, then x is the distance of this point from y-axis and y is the distance from x-axis. So, let us draw perpendiculars from point P on x-axis and y-axis and join OP. Now, PA is perpendicular from P to x-axis and PB is the perpendicular from point P to y-axis, and OP is the joining of simply O and P point. Let me directed it from O to P. Now, as we know that OA is equal to x and OB is equal to y. Now, OB and PA are same, so we can write PA as also equal to y. As here we are talking about vectors. So, this distance x we only is with us. Now, to give it a direction, let us take I cap and j cap as the unit vectors, where I cap is along x-axis and j cap is along y-axis. So, if we multiply this scalar part, that is distance x, with I cap, we are getting vector quantity now. Similarly, by multiplying y with j cap, we are getting a vector quantity. So, means now OA is a vector directed from O to A, and similarly OB is a vector directed from O to B. So, by multiplying a scalar with a unit vector, we can convert it into the vector quantity. Now, using triangles law of addition, triangles law of addition in triangle OPA, we are having vector OP is equal to vector OA plus vector AP. So, let us write OP vector is equal to vector OA plus vector AP, and we have taken AP as equal to OB. This is clearly we have shown over here. So, this AP can also be written as OB, and this OA is XI cap plus OB is YJ cap. YJ cap. So, therefore, we are having OP vector is equal to XI cap plus YJ cap. So, this is the component form of a vector, where OA is called the component along x-axis and OB is the component of OP along y-axis. Or we can say XI is the component of OP along x-axis and YJ is the component of OP along y-axis. Here I need to specify that if we are talking about XI cap and YJ cap, these are the vector components. These are the vector components because vector quantity is also multiplied by this. But if we are only talking about x and y, then these are called the scalar component of vector OP. So, x and y simply are the scalar components of vector OP, and xi cap, yj cap are the vector components of vector OP. Now, from here, I want to tell you one thing more, that if we are talking about this triangle OPA, then this is nothing but simply right triangle. So, from here we can calculate OP as x square plus y square root of it. That is by using Pythagoras theorem. Okay. So in other sense, we can write OP vector and its magnitude as x square plus y square root of it. So the magnitude of vector OP is simply the sum of square of scalar component along x-axis and y-axis and taking root of it. So this is the magnitude of vector OP. Now if we talk about the component form of vector AB, means joining 2 points. In the above discussion we have taken only 1 point, but here I am taking vector AB directed from A to B with 2 points A and B. Let the coordinates of x1, A is x1, y1 and coordinates of B are x2, y2. So if we need to find out vector component form of this vector AB, then it will be vector AB is equal to x2 minus x1 I cap plus y2 minus y1 j cap. This can be easily proved by taking coordinate plane over here and drawing perpendicular from A and B to x-axis and y-axis. So the vector component of AB are x2 minus x1 I cap and y2 minus y1 j cap, whereas the scalar components are x2 minus x1 and y2 minus y1. So this is how to represent a vector along the axis when vector is here, which is having the 2 points, that is A and B. This was all about the 2 axis, that is x-axis and y-axis. If we want to calculate the component of a vector along x-axis, y-axis and z-axis, then it will be simply, let me take vector PQ in 3-dimensional, that is with along x-axis, y-axis and z-axis, then it will be simply x2 minus x1 I cap plus y2 minus y1 j cap, and will include the third coordinate also, that is z along z-axis, and which is z2 minus z1 k cap, where k cap is the unit vector along z-axis. Now magnitude, as I told you, in case of x-axis and y-axis, magnitude we have calculated as x square plus y square root of it, which I have given the name as OP. Now if we take the 3 axis, then magnitude is equal to square root of x square plus y square plus z square, in case when we are having 1 point and we are calculating position vector of OP. Now if we are calculating vector AB or PQ, as I told over here, then its magnitude is given by magnitude of vector PQ. This is magnitude. You should put modulus sign over here. So magnitude PQ will be x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square and square root of 8. So this is how to calculate magnitude and component of a vector along the 3 axes. Now next, let me discuss about how to calculate unit vector. So to calculate unit vector, let me talk about one of the vectors. Suppose a vector given to us is vector A is equal to xi cap plus yk cap, yj cap plus zk cap. Now if we need to calculate modulus of vector A, then clearly it is x square plus y square plus z square and root of it. Now the next, how to calculate unit vector. As I just mentioned over here that unit vector is represented by a cap. A cap means unit vector of A, and it is nothing but simply vector A upon vector A cap. Why this is so? Because unit vector is the vector which is having its magnitude as 1. We have discussed the definition of this unit vector like this. So if we divide a vector with its magnitude, then the magnitude of this unit vector will be 1. That's why A cap is equal to vector A upon modulus of vector A. Now the next, let me discuss about direction ratios and direction cosines of a vector. We know that if a vector is there in a coordinate plane, then it will certainly make some angle with x-axis, y-axis and z-axis. So direction cosine is the cos of angle made by a vector with the 3 directions. If let me visualize it by drawing a figure. There is a 3D plane with y-axis, x-axis and z-axis, and O is the origin. Let AB is the vector. Certainly this vector AB will make some angle with x-axis, y-axis and z-axis. Let us take that alpha is the angle which the vector AB makes with x-axis is alpha, and with y-axis let the angle be beta, and with the z-axis angle be gamma. So we are having cos alpha, cos beta and cos gamma as the direction cosine of vector AB. Now direction ratios are the numbers which are in proportion to the direction cosine, and generally we represent these direction ratios by A, B, C. One more relation we are having for this direction cosine, and this relation is cos square alpha plus cos square beta plus cos square gamma is equal to always 1. So ABC are the direction ratios, cos alpha, cos beta, cos gamma are the direction cosines, which can also be sometimes represented as L, M, N. L is cos alpha, M is cos beta and N is cos gamma. Now let us take one example in which we will explain everything, that how to find out position vector, unit vector, direction ratios, direction cosines and magnitude. In this example, we need to calculate a unit vector along the vector PQ. Where P and Q points are given to us, we need to find out direction ratios and cosine of vector PQ as well. So, first of all, we will calculate position vector of P, which is equal to y cap plus 3j cap minus 4k cap. Then, position vector of Q, which is equal to 4i cap plus 5j cap minus 2k cap. So as we have discussed, vector PQ is equal to position vector of Q minus position vector of P, which is equal to 4i cap minus 2i cap, that is we are having 2i cap. 5j cap minus 3j cap is plus 2j cap, and the next minus 2k cap plus 4k cap is plus 2k cap. So this is the vector PQ. Next we need to calculate unit vector. So as we know, unit vector of a vector is vector upon its magnitude. So we need to calculate PQ magnitude as well. And we know that magnitude is 2 square plus 2 square plus 2 square and root of it. So I can write it as 4 plus 4 plus 4 and square root of 8. So we are having square root of 12, or we can say 2 root 3. So this is the magnitude of PQ. Now unit vector. Unit vector PQ, unit vector PQ, or we can say PQ cap, or if we are naming this PQ as vector A, we can write over here as A cap is equal to vector A upon modulus of vector A. So vector A is this with us, so it is 2 upon let me write first of all this whole A vector, 2I cap plus 2J cap plus 2K cap upon modulus. Modulus is 2 root 3. So the unit vector with us is I cap upon root 3, or you can see 1 upon root 3 I cap plus 1 upon root 3 J cap plus 1 upon root 3 K cap. So this is the unit vector, first part. Now the next we need to calculate direction ratios. Direction ratios. As I told you, direction ratios are the numbers which are in proportion to direction cosine. So if we take the proportion of these three, it will be 1, 1 and 1. So therefore direction ratios are 1, 1 and 1. We can also say that the vector that we are calculating over here, if we are taking its coefficients, the coefficients of I, J, K are 2, 2 and 2. But if we simplify these, then this is 1, 1 and 1. So we can write it as, because I cap plus J cap plus K cap. So the coefficients of I cap, J cap, K cap is 1, 1 and 1. So therefore from here also we can calculate direction ratios. Now the next is direction cosine. So direction cosines are the coefficients of I, J, K in case of unit vector. So therefore direction cosines are 1 upon root 3, 1 upon root 3 and 1 upon root 3. One thing more I want to add over here, that suppose a vector B is given to you. Suppose this is 2I cap plus 3J cap minus K cap. And there is not a question like that you need to calculate unit vector B. The question is only you need to calculate direction ratios and direction cosine. So what to do over here? You need to just find out direction ratios. So the coefficients of I, J and K are the direction ratios. That is 2, 3, 1 are the direction ratios. And direction cosines can be calculated by dividing the modulus of vector B. Means by dividing each term by 2 square plus 3 square plus 1 square and root of it. So we are getting it as 2 upon 4 plus 9, 13 plus 1, 14. That is root 14. 3 upon root 14 and 1 upon root 14. So if you need to calculate directly the direction ratios and direction cosine from a given vector, then there is no need to go to this process. That is, there is no need to calculate unit vector and then the direction ratios and cosine. You can directly calculate direction ratios and cosines from the given vector. Next, let us take section formula. Before going to use of section formula in vectors, let me recall you the section formula that you have used in case of coordinate geometry in 10th class. If you remember, then here you are having a line and there are the 2 points, let A and B, having its coordinates x1, y1 and x2, y2. And let there is a point C between A and B, so that the ratio in which this point C divide AB is m ratio n. M ratio n. So you know very well, to find out the coordinate of point C, let xy be the coordinate of point C, then you know that coordinate of point C are x is equal to mx2 plus nx1 upon m plus n, and y coordinate is equal to my2 plus ny2 upon m plus n. This you know very well. So the same thing we are going to use in case of vectors. Instead of taking just points, we'll calculate the position vector of these points and then we'll calculate the coordinate of the third vector C, which is dividing the given vector in the given ratio. Let me discuss it in case of vectors. Let AB is the vector directed from A to B and C is any third vector which divide AB in ratio M ratio N. So let us suppose that A is the position vector of point A and B is the position vector of point B and C is the position vector of point C. So as just we have done over here, it is simply the position vector of point C will be equal to B vector into M, or you can say M into B vector plus N into A vector upon M plus N. So instead of taking coordinates, we will take just the position vectors of the point A and B. So this is the section formula for vector when it is divided internally. Now this is for internally. Now if division is external, means the point C lies outside B somewhere, then this vector C is having its position vector as M B vector minus N A vector upon M minus N. So this is how to use section formula in case of vectors. As the case in coordinate geometry we have studied, if we are talking about midpoint, if C is the midpoint, then vector C is simply vector A plus vector B, position of vector A plus position of point B upon 2 only. So this is if C is the point which divides the vector AB at the midpoint. So this is all about position vector, component of a vector and section formula. I hope you understood all the concepts very well. So do more and more questions from all these 3 topics. In my next video, I will explain dot product of vectors, which is very, very important.